Section 3-6 is ratios and proportions. So a ratio is a comparison of two numbers by division. Ratios can be written several ways. So the ratio of x to y can be represented by simply saying x to y. We can use a colon, 2 dots, or the more familiar form of the ratio, which is with a division symbol. So an equation stating that two ratios are equal is a proportion. So if I have x over y equal to w over z, that's two ratios equal to each other. We call that a proportion. They are proportionate. So let's see. Determine if these two ratios form a proportion. So here's the first. There we go. Are 4/5 and 24/30 proportional? So to determine if they're a proportion, we set them equal to each other, and we try to decide whether or not they are. So let's look at this, and I know that you all know cross product, but let's look at this first a different way. If I simplify 24 over 30, both the top and the bottom are divisible by 6. I don't think I can simplify 4/5. But if 6 goes into 24 4 times, and 6 goes into 30 5 times, I can simplify this part of the proportion and show that they are equal to each other. Let's look at another one. 3/7 equals 1.5 fifths. Well, it looks like if I multiply this by 2, I will get the right numerator, but the denominator will not be the same. So these are not proportional. Okay? Now let's look at it another way, and I know you're familiar with this way. In a proportion, the product of the means is equal to the product of the extremes. Let's see what that means. If A over B equals C over D, in a proportion, A and D are called the extremes because they're the first and the last. They're the extreme ends of the proportion. They're the one we say first and the one we say last. B and C are the means. They're in between. We say the product of the extremes equals the product of the means. Therefore, A times D equals B times C. And we sometimes call this the cross product. Now, I do not want you to confuse things. This is used for a proportion. This is used when two fractions equal each other. So if I have 3 over 7 equals 6 over 14, I can say that the product of the extremes, 3 times 14, equals the product of the means, 6 times 7. If I multiply 3 times 14, I get 42, and 6 times 7 is 42. That's what we use cross product for when we have a ratio, two fractions equal to each other. When we have a multiplication problem, that is not a proportion. We do not use the cross product. We simply multiply across 3 times 6 divided by 7 times 14. Numerator times numerator, denominator times denominator. So I get 3 times 6 is 18. 1 times 4 is 28 to 98. Okay? Very, very different. This is a proportion. We can use our cross product. This is a multiplication problem. We multiply across. Make sure that you understand the difference between these two. This is a really common error that is made, so please make sure you look at this, and if you have any questions, ask me. All right, so sometimes you're asked to solve for a missing piece of a proportion, and since it is a proportion, I can use cross product. So x times 20, which normally we write 20x, equals 3 times 8. So 20x equals 24, and x equals 24 divided by 20, and I can simplify that a little bit. So I can get, I can divide both of those by 4 and get 6/5. Okay, let's try another one. Oops, I guess I just gave you one of those. All right, let's go on. Ratio. A ratio of measurements, or excuse me, a rate is a ratio of measurements having different units of measure. And we can come up with lots of examples. $20 per person. The numerator is dollars. The denominator is people. Okay? 55 miles per hour. The numerator of this ratio is miles, and the denominator is hours. 60 seconds per minute, we've done that. 30 feet in 10 seconds. That means that the numerator is feet and the denominator is seconds. So those are rates. Anytime we have units and the units of the top are different than the units of the bottom, we call it a rate. It's a specific kind of ratio. So you go on a 45-mile bike ride. It takes 6 hours. At this rate, so the rate they're talking about is 45 miles for every 6 hours. The question is, how long will it take to go 60 miles? I'm going to set up a proportion because I am keeping the same rate or ratio, but now I'm going to change my distance to 60 miles, and I want to know how many hours. So, using a cross product, or I could simplify this side first because 45 and 6 are both divisible by 3. So 3 goes into 45 15 times. 3 goes into 6 2 times. So 45 miles in 6 hours is the same as 15 miles in 2 hours. And now I'm going to compare it to my 60-mile trip. Cross product, 2 times 60 equals 15 times x. 2 times 60 is 120. Divide by 15. And those are both divisible by 3. But I really want to know how long it takes. So let's see. That's my time now. That's all my hours. So 120 divided by 15. Let's see. Let's try 8. 8 times 5 is 40. 8 is 12. That works. Okay. So x equals 8 hours. Okay. Let's try another one. Where did my clickers go? Huh. I've lost my move it forward click. Well, let's see. Not sure how to get there now. Well, all right. Well, let's try one more. I think I had one more on another slide, but I'm going to do it on this slide because for some reason I'm not able to forward my slides all of a sudden. So let's see. I think I had, well, you know what? I think that whatever my last example was, we'll do together in class. So we'll call it quits for this video, and